Okay, welcome once again to my YouTube channel. So I want to continue from where I stopped in my last video. So in the first video, under the techniques of performing differentiation, which I shared with us, we have three techniques. We have chain rule, product rule, and quotient rule. And I started with chain rule. So I gave the first lesson there, which is called lesson 1. You can check my YouTube channel. You can see that video there, the lesson 1 of using chain rule to perform differentiation, some of the critical differentiation that looks. I explained everything there, when to know when to use chain rule and all that. So I want to further it by giving us more example using a polynomial function, because the function you are looking at on your screen is polynomial function. So I want to perform that using these two examples that is there to expound it more and all that. Okay, given the first one, which is a here, which is there, so I have y equals to 1 minus 2x raised to power 3. First of all, let's now apply. We have y equals to, this thing can still be transformed into to be y equals to 1 minus 2x raised to power 3 raised to power half and all that. So now it has this. Now you now say let u equals to 1 minus 2x raised to power 3. So now we now have the u over the x is equals to 1 is 0. Differentiating or differentiating this will give you minus 6x square. So we are through with that one. Remember that according to what I taught you, we have y now be equals to u raised to power half. Then dy over du will give me 1 over 2 u raised to power minus half. When you subtract 1 from half, it will give you minus half and all that. So we now have that is minus half of this. So we're now going to have dy over du equal to 1 over 2 times 1 over u raised to power half, which is dy over du will be equals to 1 over 2 times 1 over square root of u, which will give me finally dy over du will be equal to 1 over 2 root u as my dy over du. We know that dy over the x will give me dy over the u times du over the x, which will now be my dy over du is 1 over 2 root u times my du over the x is minus 6x square. So when we multiply now, dy over dx will now be equals to minus 6x square all over 2 root u. 2 will cancel out. Then dy over dx is equal to minus 3x square all over root u. But u is equal to 1 minus 2 x raised to power 3. So we are going to substitute. So dy over the x finally is going to be minus 3x square all over root 1 minus 2 x raised to power 3 as your answer. Okay, the second question is y equals to 1 over root of 1 plus x squared. So in this case, we're going to have y. First of all, we're going to apply indices here, law of indices here. We're going to have 1 plus x squared raised to power minus half. Another. So now let's u equal to 1 plus x squared. So now we have du over dx is going to give me 2x. Then y will now be equal to u raised to power minus half. Then dy over du is going to give me minus 1 over 2 u raised to power minus 1 over 2 minus 1 will give me minus 3 over 2. So this one will be minus 3 powers minus 3 over 2. So in this case now we have dy over du is going to be minus half times 1 over u raised to power 3 over 2. Then dy over du will now be equals to minus 1 all over 2. So let's consider this thing because 2 is at the denominator of the fraction of the power. So 2, because we're going to have square root of u. 3 is at the upper part, raised to power 3. So we have gotten the value for dy, but remember that dy over dx is equals to dy over du times du over dx. So dy over dx is equal to, my dy over d is minus 1 over 2 root u raised to power 3 times 2x. Finally, dy over dx will now be equal to minus 2x all over root of 2 u raised to power 3. So remember that u raised to power 3 is 1 plus x. So now I'm going to have dy over the x equals to, first of all, these two will cancel out. Will give us minus x all over root of u is 1 plus 2x squared, 1 plus x squared raised to power 3 as your answer. So feel free to subscribe to my YouTube channel. Remember to turn on the notification bell for more videos like this. Thank you and God bless you.